Today I'll be presenting on loop quantum gravity, and I'll be comparing and contrasting with string theory since we have already learned about that. I'm hoping that'll make it easier to understand this complicated theory, and I'll also be revealing another reason for that towards the end. Mr. Nichols already introduced us to the founders here, but he also explained that they took a controversial route to this. Let's take a look at why. In comparison, other theories such as string theory started off background dependent on the standard model of physics, which means they can't violate those laws. And then they're attempting to try and solve for quantum gravity through general relativity, and they're failing. So, loop quantum gravity theorists were originally quantum physicists to start with. They decided, we'll take a different route. We'll think outside the box. We'll cheat. Let's cheat. Let's just go straight to the hard problem. Solve it. If we can solve that, we already know quantum mechanics. We can go right back to what we know. And then we can solve for the rest of this easily because everybody else is doing it. Why can't we? It's so easy. Everybody's doing it. So by doing this, they're background independent of the standard models of physics. And Abdi Ashtekar was able to solve this by rewriting Einstein's equation. What? No, you can't do that. Well, yeah, you can. Remember, they're quantum physicists, which is a lot more new information since Einstein's time. He used variables that are new and rewrote his Einstein's field equations in an equivalent manner, so it's completely equal, but it's more workable with modern physics. So they solved for this. But what they did is they didn't create a grand unified theory like they're originally thinking. They created yet another standalone model of physics which represents space-time itself. Since it represents space-time, we would say that it's background independent of space-time. Well, what does that mean? Let's compare that to string theory. We know that strings are vibrating and they're attached to space-time, so thus we would say it's background dependent on space. Loop quantum gravity offers more scientific testable predictions than string theory because of this fact. That also arises some controversy because everybody's like, no, you must be background dependent on the modern standard models of physics. Loop quantum gravity has a cyclic universe model of expansion, which I'll get to more here briefly. But just as a reminder, we know from string theory it can be a big bang from two brains touching, or an expansion or collapsion of a brain. LQG has no extra dimensions, no higher dimensions, no supersymmetry, no wormholes, no firewalls, and no extra universes. Where, according to Brian Greene, who's a string theorist, all of that exists except for firewalls because, those are pesky and getting away with his precious wormholes. And then other string theorists, they put in the firewall just to shut them up. No, as we learned from the lecture on black holes, it's there to explain the anomalies that occur beyond the event horizon. Mr. Nichols already introduced us to Carlo Rovelli and spin foam theory, but I'm going to touch on it briefly. Spin foam theory, remember, he's also a loop quantum gravity founder. He started this to replace string theory. This is their version of string theory that's going to link to loop quantum gravity and create a new grand unified theory. The spin of the loops create almost identical calculations to the vibrations of string theory. And then the foam only represents the probability distribution of where that loop is in its spin. Here I found a really good picture representing the four-dimensional space-time loops that Mr. Nichols explained to us in depth. Here's the foam network that he described. And I'm bringing this up again because it can twist and turn. I've got my rubber bands, but it twists and turns depending on how it interacts with matter in space. And then the spinning loops, they spin within the voids. And that limits their size just like there's limits in string theory. Now we're moving on to Martin Bojowl. Something creepy about this puppet though. I love it, but something creepy. Here we have a representation of his big bounce, which here we have a rubber band stretched across the room. Whoa. It's a collapsing universe. It's going to collapse and bounce back out. It just doesn't disappear to nothing like you would with working backwards. Got the bounce, follow the frame of reference, it actually expands all the way back out, and that's what he's saying. Here's another representation of it. You have somewhere here would be our current universe, and eventually we're going to hit a critical, and then we're going to collapse back down into a singularity, not zero, not coming from nothing, and then it'll explode or bounce back out into another universe. So it's a cyclic universe model where it just keeps recycling. Loop quantum cosmology is also working on very, very specific signatures in the cosmic microwave background and black hole entropy and Hawking's radiation. Now for the big reveal. Whoa, not talking about the guy's eyebrows that are hair, but he's working on combining loop quantum gravity as space-time and string theory connected to that, adding higher dimension supersymmetry and de Sitter mathematics. What I want you to take away from this presentation is next time you have a problem you can't solve, think outside of the box, and you never know when somebody else might be holding on to the answer to your problem. How much time?
24 seconds.
Who actually believes loop quantum gravity better unites quantum mechanics with general relativity than does string theory. You kids have fun.
Hang on a second. Loop quantum gravity clearly offers more testable predictions than string theory.
I'm listening. Amuse me.
Okay, well, for one thing, we expect quantized space-time to manifest itself as minute differences in the speed of light for different colors. Okay, well, there's loop quantum gravity calculates the entropy of black holes.
There's the entropy of black holes I mentioned. All right, field questions. Feel free to answer what I already know.
All right, I'd like to start out. Okay. Let's start.
Okay.
That's about the most concise and clear explanation I've had of loop quantum gravity. So that was a really good job.
Thank you. Thank you.
And
I've watched a lot of videos.
I think that it would be really cool, maybe if you present to the astronomy club or something like that. You could talk to Professor Dunn about that. Because
Okay.
very interesting.
Yeah, there's some other points to it that I left out for the time constraint.
Obviously.
But if they are successful, the big controversy I mentioned, they're not background dependent on the standard models. Yeah, but then again, where were we before the standard models? We built up from somewhere.
See, now what he just did right there is he took the question and answer time and he used that to talk more about his content that he wanted to talk about, right? Now, see, that's a good thing to do. If you're giving a presentation and you don't have enough time to talk about everything you want to talk about, take a question and then meld it into an opportunity for you to talk about more about what you want to cover. It's like, I'm sorry.
No, that's exactly what I did. I started off with almost an hour worth of information, and then I figured out what I don't have time for and phrased questions.
Yeah.
Actually, I think there's a double on your papers that I handed out for the extra credit.
So I'm telling you, you probably studied more about loop quantum gravity than I have. And so as you find that loop quantum gravity arrived from quantum mechanics scientists trying to address the issue and not going through any of the concepts of general relativity or anything like that. They just started from quantum and tried to engage a quantum theory of gravity.
Well, they went through general relativity. They were quantum physicists. They're like, we're having trouble. We need to solve for quantum gravity. So they're looking at where everybody else having a problem. So they, like I said, Abdi Ashkar rewrote general relativity's field equation, and then they solved for quantum gravity that way. And the model that they created is not just for quantum gravity, but encompasses all space gravity. Yeah, but they still got to work back to the standard model. Otherwise, the controversy, everybody's like, well, you're offering these predictions, but there's no standard model, so we're just going to ignore your results, even if they're correct.
Well, any questions here? Here's what